Okay, so the key to this one, just like in the last couple examples we've seen, is figuring out how to divide it up. As we look at this one, oops, don't know what's going on there, get away. Obviously I can see that there's a rectangle here and a rectangle here. This rectangle is 20 feet wide, but how long is it? Do I know the radius of this piece here that's a half circle? Yes, it has a diameter of 80, so it'll have a radius of 40 feet. Perfect. So this here is 40 feet. This here then is also 40 feet, which makes this length 200 minus 40 minus 40, or 120 feet. So that rectangle, which I'm going to call shape 1, is 120 feet by 20 feet, or 2,400 square feet. This rectangle up here is the exact same size, 2,400 square feet. Next, we have these not so innocent looking shapes. That one and this one. Well, what we're going to do with those is kind of like what we showed in the last picture. We're going to pull them out. Come on. Put them together like that. Now what we have here, again, if my artwork were better, this would be clearer, is we have a big circle with a little circle cut out. The big circle we know has a diameter of 80 feet, or a radius of 40 feet. We know that this is 20 feet from this right here, right? 20 feet thick. So if that's 20 feet, what is the radius of the little circle? It's also 20 feet. 40 minus 20 is 20. So the area of that is a large circle, which will be pi times 40 squared, otherwise known as 5,024 square feet, minus a smaller circle, which is pi times 20 squared, otherwise known as 1,206 square feet. Subtracting gives me 3,818 square feet. That is the area of that donut shape, or that washer, if you want to call it that. So we add that on to our total to get 8,618 square feet is our area. Now, what if I were to ask you to find the perimeter around the outside of this? Would that be very tough to do? Well, no, if I'm going to add this up, this is 120, this is 120, right? So if I'm finding the perimeter, I have 120 feet plus 120 feet, plus the distance around this circle here is the distance around those other two pieces. That circumference is 80 times pi, or 2,412 feet. Sorry, 241.2 feet. giving us a circumference of 481.2 feet. Questions? I know I went through that circumference kind of fast, that perimeter kind of fast. But all it is adding up the sides just like before. You've got this side and this side, and I combine this arc and this arc to make the one full circle. I could find the perimeter on the inside the same way, but I'm not going to bother with it. How are we feeling? Peachy? Got a headache? That headache might hang on for another 3 weeks or so, just so you know. Anyway, sorry. We briefly mentioned before the concept of volume. Now remember we said area is you take a length and you move that length a distance perpendicular, and that creates an area. And the length times that distance is the size of your area. For a rectangle, that became length times width. Volume is the same way. Let's say that we have an area. And this is a rectangle. It's just we're looking at it from a funny angle, so it looks kind of like it's kind of slanted over. And we take that area and we pull it through space. We've done this analogy before. In a direction that's perpendicular to the original 2, so we pull it straight up. These are all right angles here. We create a volume, and the volume is equal to the area of that base times the distance that we pull it, which we're going to call the height. So volume is area of a base. A with a little b is area of a base times a height. We've mentioned before that volume of a box is length times width times height, right? Volume, length times width times height. Well, you can see here length times width is just the area of the base. So it's the same formula, just I wrote it out a little different. The reason I write it out a little different is because when I write it this way, it applies to pretty much any shape, any regular solid. So let's do some examples here. Pretend that looks like a regular base. So let's say that this is 10 feet, 12 feet, 8 feet. To find the volume, the first thing I'm going to do is find the area of the base. Now the base is not always the bottom. The base is the shape that we said you grab onto and pull to create the whole thing. Now in the case of a box like this, a regular box, any of the sides can be a base. I could grab the bottom and I could pull it up through, I could slide that bottom up through this piece to make the whole shape if I wanted to, see, like that. But I also could grab one of the ends. I could slide that through to make the whole shape, as you can see there. Or I could grab the back if I wanted to. I could slide that through to make the whole shape, as you can see. So any side of this could be the base. So since that's the case, I am going to select the bottom just to make it easier. So it's going to be 12 times 8, so 12 feet times 8 feet is 96 square feet. So then my volume is the area of that base, which is the 96 square feet, times my height of 10 feet. 96 times 10 is 960. Square feet times feet is feet cubed, or cubic feet. let's look. So that's a box. I mean, that's pretty simple. But let's look and see what happens if it's not just a regular box. Here, this is not a regular box. The base of this is this triangle here. Because that triangle is the shape that I can slide through the whole object. I can pull through space to make the whole object. So to find my volume, I start out by finding the area of the base, which is going to be 6 inches by 8 inches. What do I have to remember? Divide by 2. Why did I divide by 2? Because it's a triangle. Gives me 24 inches squared, square inches. So now to find my volume, I take the area of that base. 24 square inches times what? Now my height in this case doesn't go up and down. It's the dimension that goes between the two bases, which is the 20. So 24 times 20 is 480. Square inches times inches is inches cubed. What do you think? Loads of fun? Okay, well, let's take a look at something like this. Pretend those look like circles. This is a cylinder. Another reason why I define, bless you, okay? Another reason I define my volume as being the area of a base times the height is because of cylinders. There's no special formula for cylinders. Let's say that this across here is 8 feet. And this is 10 feet. To find my volume, I approach it the same way. How do I find the area of my base? My base here is a circle. Circle has a radius of 4 feet. So that'd be pi times 4 squared, which is 50.24 feet squared, not inches squared. Feet squared. Everybody see where the 50.24 comes from? Any questions? That is just a circle, so we go back to our formula for a circle. How do we find the volume? Yeah, the area of my base, 50.24 square feet, times my height of 10 feet of height is 502.4 square feet times feet is cubic feet. And this all applies to even some of our more complex shapes. I could draw out something really nasty like this. Yes, I'm cheating. I want to find the volume of this. To find the volume, I'm going to start out by finding the area of the base. The area of this base is not a simple picture. But I can do this. I can cut it across there. I have a half circle. Cut it across there. I have a rectangle and a right triangle. So I'm going to find my three pieces. Piece number one is a rectangle. This length of the rectangle here is 8 inches by, what's the width? Yeah, this is a radius of 4. 4 plus 4 is 8. It's actually a square, not a rectangle, isn't it? 8 by 8 is 64 inches squared. Piece 2 is a triangle. This is still 8. What's this dimension here? 6, yeah. 14 minus, this is 8. 14 minus 8 makes 6. What do I have to remember to do? Divide by 2, because that is a triangle. So that is going to be 24 square inches. And then piece 3 here is a half circle. To find the area of a circle, it is pi times radius, so pi times 4 squared and divided by 2, because it's only half a circle, which gives 25.12 inches squared, which adds up to give us a complete area of the base of what? 113.12 inches squared. Does that look correct? Looks good to me, right? Any questions on where I got the area of the base? All I did was I took the base, which is this bottom piece. I actually did it on top so I could see it better. And I cut it up into pieces that I knew how to find. Rectangles, triangles, and circles. Now that I know the area of the base, the volume is quite simple. It's the area of that base, 113.12 square inches, times my height of 10 inches. Which is 1,131.2 inches cubed. What do you think? Good stuff? What's that?
All I can say is I don't know.
That's your chance. Okay, so pyramid. Our volume is still going to go off of the area of the base and the height. But obviously it's not the full thing, because the box that would contain this full thing is considerably bigger, right? Now when it came to dealing with triangles and area of triangles, what did we do to the area of the rectangle? We just divided it by 2. But if we compare here, if we had a rectangle We cut it in half, we had a triangle. Well, let's take a look at a box. If we have a box, if I cut that box in half, do I get a pyramid? No, what I get is a wedge, isn't it? I don't want a wedge, I want a pyramid. That pyramid is less than half. It's smaller than the wedge. If I cut it again in this direction like this, now I have a pyramid. Now what I took off was not half of the remaining volume, because what I took off was up here at the point where it was smaller. Now here's one of the few spots where I'm going to have to ask you to trust me. We know what we can see here is that this is less than half of the whole box and more than 1/4 of the whole box. What it comes out to be is 1/3 of the whole box. So the volume of a pyramid is the area of the base times the height divided by 3, or 1/3 of the area of the base times the height. The way I remember that is, again, looking back here at the triangle. That triangle area was length times width divided by 2. How many dimensions is a triangle? 2 dimensions, right? It's flat. 2 dimensions divided by 2. For the pyramid, the volume is area of the base times height divided by 3. How many dimensions is a pyramid? 3 divided by 3. That's the way I remember it. So anyway, back down to here. We're only going to deal with pyramids that have square bases just because, well, I don't hate you that much to make you do non-square bases. I don't hate you at all, just for the record. So the area of my base is what? (16 times 16), right? It's a square, actually, it's just a rectangle. 16 times 16 is 256 inches squared. So then what do I do to find my volume? My area of my base, 256 inches squared, times what? My height of 15 inches, divided by 3 is 780 inches cubed. What do you think? Questions? It's not so bad, is it? Now, with that knowledge in mind, what's that? Oh, sorry, it should be 1280, shouldn't it? Does that sound better? Yeah, sorry about that. 1280. It's one of those days. Sorry about that. That should be 1280. The internal calculator still on the weekend. Okay, so down here, let's take a look at a cone. It has a 10-inch circular base and a 12-inch height. Based off what we just did, this should not be very difficult. The cone follows the same rules as the pyramid. The volume is the area of the base times the height divided by 3. So let's start out with the area of the base. Tell me how to find the area of the base. It's a circle, yep. So it's going to be pi times what? 5 squared. Otherwise known as 78.5 inches squared. Then what? Okay. Our volume, 78.5 inches squared times 12 inches divided by 3. 314 inches cubed. Correct? Any questions? Bless you. Bless you. It's contagious. Yep. I can prove scientifically that yawns are contagious, but I didn't know sneezes were too. There you go. Okay. How do you guys feel about these? Terrible? Oh, come on, they're fun. Yeah. Let's talk surface area. Surface area is the amount of surface that covers an object. It's an area. So if I'm dealing with a box, like I have been, by the way, for those of you that are struggling to draw these boxes, an easy way to do it is to draw a rectangle like this. Just make a dot up and over from each corner. Draw another rectangle the same size, then connect the corners. Does that help? Should have showed you that half hour ago. Sorry. So let's say that's 8 inches, 7 inches, and 12 inches. Surface area, I could just take all of the surfaces. Like this here is 12 by 7. I could find the area of that rectangle. This here is 8 by 7. Find the area of that rectangle. And the back here is 8 by 12. Find the area of that rectangle. And then, of course, they each have a double. So I double each of those, add them each in twice to get the whole surface area. Does that make sense? That's one way to do it. But I'm going to come up with a shortcut for you. There are two types of area here. We've already talked about the area of the bases, right? The area of the base, we're just going to choose the bottom to be the base again. So for this, that's 12 inches times 7 inches, or 84 square inches. Now that, of course, also takes out the top. So there's a second base, another 84 square inches. So you can see I'm adding it in twice over here. The rest of this, the area, the rectangles, as if you will, that connect the two bases are what we call lateral area. Lateral area can be peeled off. If I were to cut it down this corner here and peel it off, I would have this rectangle on the end, then this rectangle on the back side, then this rectangle on the end, then this rectangle on the front side. And what I get is one big long rectangle. What is the height of this rectangle? still the height of the whole box, the 8 inches. What's the length? The distance around the base. It is the perimeter of the base, which is 7 plus 12 plus 7 plus 12, or 38 inches. So lateral area, or sometimes called lateral surface area, is the perimeter of the base times the height, which for this figure is 38 inches is the perimeter of the base times the height of 8 inches, which is what, 304 inches squared. I think that's right. Now note, I still have to add the 84 and the 84 to that 304, don't I? So I take the 304 plus 84 plus another 84. Is what, 472 inches squared. Now again, the reason why I define area like that instead of just doing the 6 rectangles and adding them up, or the 3 rectangles and doubling them and adding them up because they've got the same on both sides, is because not all figures are going to be nice little boxes like this. We run into cylinders. And let's say that my cylinder here has a radius of 5 feet and a height of 20 feet. The area of my base is pi times 5 squared, or 78.5 square feet. That's the bottom here. What do I have to do next? Well, I've got to remember the top is the same. 78.5 square feet for the top. To find the lateral area, I need to know the perimeter of the base. How do I find the perimeter of the base? Diameter, which is how much in this case? 10 feet, double the 5, right? Times pi, which will be 31.4 feet. So my lateral area is that perimeter of the base, 31.4 feet, times my height of 20 feet, which gives me 628 square feet. I add that to my 78.5, and my 78.5 is 785 square feet is my total surface area. Questions? Let's see how much attention you've been paying. In your notes, find the surface area of that for me. What's the first step? Area of the base. 6 times 8 divided by 2. 24 square inches, the area of the base. Is there another one on the other end? Yes, there is. There's another 24 square inches. Now to find our lateral area, what's the first thing we need to know? The perimeter of the base, and to do that we need to know the hypotenuse. You got it. What's this come out to be? 10 inches. 6 squared plus 8 squared equals, if I call that x squared, or c squared, it comes out to be 10. So the perimeter of my base is 6 plus 8 plus 10, which is 24 inches. So my lateral area is the perimeter of my base, which is 24 inches, times 20, or 480 square inches. So that makes my total surface area 528 square inches. Very good. Anybody get that? Heard 1, 2, 3 maybe? Okay. It's a matter of just putting all the little pieces together. So let's go back to this pyramid thingamajigger. That's the technical word for it. To find the surface area, I will still start out with the area of the base. The base here is just 16 by 16. It's a square. 256 square inches. Is there another base? In this case, no, there isn't. That's the only one. So now we need to look at the lateral area. To find the lateral area, I need to know the perimeter of the base, which in this case is 16 plus 16 plus 16 plus 16 equals 64 inches. That's my perimeter of the base. However, in all of my other figures, the sides, the lateral sides, went straight up and down, didn't they? Do these sides go straight up and down? No. Is the distance from the tip of this down to here, is that going to be just my height of 15 inches? Say no. No. Why not? Because you told us so. Right? It's at an angle. This is 15 inches straight down here. That's at an angle. It's going to be greater than 15 inches. How do we find its length? Well, what's this distance here? Yeah, half of the base is going to be 8, because the peak of that pyramid better be over the center of the base. So what we have there is a triangle. Oops. There's a right angle. That's 8 and that's 15. This is my hypotenuse of C. So if you do 8 squared plus 15 squared equals C squared, C is going to come out to be 17 inches. That is what we refer to as the slant, or sometimes called the slant height. So in a pyramid, the lateral area is equal to the perimeter of the base times the slant instead of the height. Now, do those form rectangles? No, those form triangles. When we find the area of triangles, we divide by 2. So on a pyramid and also on a cone, the lateral area is the perimeter of the base times the slant divided by 2. So this is going to be 64 inches times that slant of 17 inches divided by 2, which is what, 544, I believe, inches squared. So that's my lateral area. I add it to the area of my base to get a total of 800 inches squared for my surface area. Questions? Not quite. Is that your way of saying ouch? I hear you. There's a lot to absorb here. Back to our cone. To find the surface area of a cone, we start out with, surprise, surprise, the area of the base, which will be pi times radius squared. Diameter of 10, radius of 5. So it's pi times 5 squared, or 78.5 feet squared. Hopefully no surprises there. For my lateral area, I need to know the perimeter of my base. The base is a circle, so the perimeter is going to be the circumference of the circle, which is going to be 10 times pi, or 31.4 feet. However, I also need to know the slant. The slant is going to come from this triangle. Here is my slant. This is my 12 feet of height. What's this distance down here? It's my radius of 5. So that's going to be found by doing 5 squared plus 12 squared equals s squared. Comes out to be 13 feet. So my lateral area, perimeter of the base of 31.4 feet times my slant of 13 feet. Is that it? Divided by 2. Very good. .1 square feet. I add that to the area of my base to get a total surface area of 282.6 square feet. Any questions? Since we're on a roll. Anybody tell me what that picture is supposed to be? An egg? A broken egg? Wow, you guys are harsh. It is a sphere or a ball. Now, to find the volume and the surface area of a sphere, we can derive those formulas. Problem is, that's like a third semester calculus problem to derive the formulas. We don't have that kind of time or ambition. So this is going to be, again, one of the few times where I just ask you to take my word and I give you a formula that you're going to have to write down and reuse. The volume is 4/3. That 4/3 is a constant. Times pi times the radius cubed. So here's my radius right here, from the center out to the edge of the sphere. The surface area is just equal to 4, which is a constant, times pi times my radius squared. So let's say that my radius here is 12 inches. So my volume is going to be 4/3 times pi times 12 cubed. To punch that in my calculator, I'm just going to do 4 divided by 3 times, for pi, I'll put in 3.14, times my 12 to the power of 3, and I get 7,234.56. And that is what units? Inches cubed, because it is a volume. So to do my surface area, still with that radius of 12, it's going to be 4 times pi times 12 squared, which is going to give me 1,808.64 inches squared. Is that correct? 4 times, for pi, I'll put in 3.14 times 12 squared. Oops. Get the squared in there. 1808.64. Perfect. Now any questions? The good news is, now we're done. There is a new quiz due today at 11:59 p.m. and a new homework that will be due for Thursday. Also, for those of you that took your test other than in Rice Lake here for the Superior, if you took it at Spirit in Richmond, your test 3 should be in your email, so you can work on that and do corrections on that. If you have not done corrections on test 2 yet, please feel free to keep working on those. I got them back to you late, so I'll give you till the end of this week to work on those. If you have any questions, let me know. I'd be happy to walk through any of those problems with you if you need help. Okay, well that's enough for one day. The computer labs are open if you want to work. I will be around until about noon.